Section 3 is on relative velocity. And what relative velocity is, if you're standing on the side of the road and you see a person walking kind of right in front of you on the sidewalk, so you're a little bit further closer to a building than on the sidewalk, and a car goes by, what is the relative velocity of the person walking compared to the car going by? Okay, so the way that we can find out relative velocity, we can use this formula. So the velocity of A to B plus the velocity of B to C is equal to the velocity of A to C. Or in layman's terms, the relative velocity of an object A to object C is the vector sum of object A's velocity relative to object B, and object B's velocity relative to object C. And this is pretty easy stuff. So it's not going to take too long to kind of go over this and everything. Let's kind of look at our first example. Our first example says Anna and Sandra are riding on a ferry boat that is traveling east at a speed of 4 meters per second. Sandra rolls a marble with a velocity of 0.75 meters per second north, straight across the deck of the boat to Anna. What is the velocity of the marble relative to the water? All right, so let's kind of look at this by drawing the picture a little bit. I'm not going to draw a picture of a boat or anything, but we have the velocity of boat to water, and it says it's traveling east. And we have the marble traveling north along the deck. So our relative velocity, somewhere right here at an angle. Okay, so velocity of the marble to water. I know that kind of looks like a V, excuse me. Pen's dying out a little bit. So, since the marble on the boat is traveling a different direction than with the boat in the water, what we're going to do is we're going to use the Pythagorean theorem because we're trying to find that right there. So the velocity of the marble compared to the water is going to be equal to the square root of the sum of our two velocities that were given to us. So 4 meters per second, square that, plus 0.75 meters per second. That is also squared. And let's see what that comes out to be. Square root of 4 squared plus 0.75 squared. And I'm coming up with 4.069705, so let's just say 4.1 meters per second. Now, let's kind of see what the angle is that the marble is traveling at. Let's find our theta. So to find theta, let's take the inverse tangent. So the inverse tangent, what we're going to do is we're going to look at the velocity of the marble to the boat over the velocity of the boat to the water. Okay, so the velocity of the marble to the boat, we said, was 0.75 meters per second over the velocity of the boat to the water, 4 meters per second. So inverse tangent of 0.75 divided by 4. I'm coming up with 10.6 degrees. Now, which direction is it traveling? Well, we know the boat is traveling east, and the marble is traveling north. So this is 10.6 degrees north of east. Now look at our second one. Like I said, these are very easy sections to do. It says you're riding on a bus moving slowly through heavy traffic at 2 meters per second. you hurry to the front of the bus at 4 meters per second relative to the bus. So that means you're traveling with the bus. What is your speed relative to the street? Alright, so velocity of A to C. Alright, so our velocity of A to B. Let's take that as the bus moving through heavy traffic. 2 meters per second. Plus. Now, you're traveling with the bus. We'll make that as B to C at 4 meters per second. So 2 plus 4 is 6 meters per second. So that is your relative velocity compared to if someone was standing on the street watching you walk up the bus as it's traveling through traffic. Well, I hope this helps you out. Look at these kind of with the homework assignment and everything. If you have any questions, please email me, and thank you for watching.